Hello students, welcome back to CLARI Concepts, Unleashing Conceptual Learning. We are here with you to make your engineering more simple and more conceptual. Okay, so visit our website clariconcepts.com for more such conceptual videos. So today in this lecture, we will be talking about the stability of floating body, and I am 110% sure that this lecture, whatever animations we have brought for you, whatever visuals we have brought for you, this will really help you to understand this topic in a better way. If you refer this topic through reference books or textbooks, you will not find it that easy to understand, and this is really confusion. I mean, the topic where student has a lot of confusions, creating it up. So let us move ahead, but before I move ahead, I would like to show you one image, rather one video. You might have seen that when you get onboarded with the ships or boats, the boat takes, it basically have some different kind of motions, and this may also frighten you up that the boat should not get toppled and all, right? But don't worry, the boats and ships are designed with more greater stability, and today in this lecture we are going to talk about the stability criteria of a floating body itself, right? So let us look at one very interesting video. I have got it for you. This is taken from Design Squad Global YouTube channel, and they are showing you the cross sectional of a ship or rather kayak. You can see when a person sits on it. Now this is the water surface that you see. This is the center of gravity of the entire person plus ship, and the blue color point is center of buoyancy. Now if you closely see, blue color is the centroid of the portion of ship which is submerged in the water surface, right? So if there is a tilt because of some waves and all, this restoring couple will help the boat to come up. But when there is a shape is circular, what will happen is the buoyancy point does not shift by much extent, and CG, so at a particular instant of orientation, this may overturn, right? And that is why the ships are having broader sections. Mostly if you see the cross-section sheet, they are broader in section, right? So that it can it can create a restoring couple and come back to its original position. So now let us see what are the criteria for this kind of stability, and how can we understand that what is stability of a section that you have designed. So we will see stability of a floating body. Alright, so there are two things which helps you in understanding this. One is metacenter, other is metacentric height. So let us first understand what is metacenter and what is metacentric height, and based after that we will understand that what are the stability criteria for a floating body. So let us imagine I have a water, I have the river or other sea water, and I have a ship which is floating on the surface of water, right? This is the cross section of ship. So let's say if ship is moving like this, what you are seeing, let's say if ship is moving like this, what you are seeing over here is the front portion of the ship. So if you see it from here, you will see something like this, the cross sectional view, right? Now let us say the entire ship has a CG somewhere over here on a center line where the weight of the ship acts, and then the center of buoyancy is somewhere over here. Now let me tell you what is center of buoyancy. It is the point where buoyant force acts. Again I am saying you, if you are looking at this video without understanding what is buoyancy, so I request you to kindly go back to my lecture where I have explained you what is buoyancy, what is buoyant force, and at which particular point it acts. If you are clear with that, then and then you watch this video, okay? So buoyancy point or center of buoyancy is a point which is basically the centroid of the portion of the body submerged in the water. So if you see what is the portion of body submerged in water, it is from this. So this particular shape of the body, and centroid of this is somewhere over here, B, and at this point the buoyancy force acts, that is FB, right? Now let's say for example, due to some reasons, maybe air or water waves, there is some tilt in the ship, some inclination of tilt in the ship for some angles, let's say from center line, right? So what will happen, let me now again locate the center of buoyancy and center of gravity. CG is over here. So whenever the ship is tilted, the CG is not going to change with respect to the ship's orientation, right? So CG will again stay at the center line somewhere over here, but the weight acts downward, W. What happens to center of buoyancy? You see initially it was over here, but when it is tilted, now the geometry of the ship submerged in water has changed. The geometrical shape has changed, and therefore the center of the shape would have been changed, and therefore the new center of buoyancy is somewhere over here. It has been shifted. So B dash. So the buoyancy force, new buoyancy force acts Fb dash over here. Now if you look at this particular orientation, one is G, one is Fb, and now from this position, let's say the wind goes away and the waves goes away, the ship come back to its original position. Why? Because this couple, the new buoyancy force and the weight will create the restoring couple, right? And the line of Fb dash that intersects over here, that point is called meta center. Now see, you remember this thing. The line of new buoyancy force, line of action of new buoyancy force, where intersects with the line of action of the previous buoyancy force, and the point where it intersects is called meta center. So what is meta center? It is the point of intersection between an imaginary line drawn vertically through the center of floating body vessel, center of floating vessel, and the corresponding line through the new center of buoyancy when vessel is tilted. So this is old, this is new, and the intersection is called meta center. Now the distance between G and M is called metacentric height GM. So greater the distance of G and M, the greater is the height, right? So this metacentric height is measured positive above G mostly, right? So what is metacentric height? It is the distance between center of gravity and metacenter of the floating body. Okay, now let me talk you about stability criteria. So when floating body is floating on the surface of any fluid, there are three equilibrium positions which floating body can have. One is floating body can be in stable equilibrium. Second is it can be in neutrally stable equilibrium. And third, it can be in unstable equilibrium. So let us see one by one all of this. So firstly, I will talk about the stable equilibrium. So let's say I have the body tilted, and because of this tilt, the new center of buoyancy is somewhere over here, and the new buoyancy force, if I draw the line of action of this, I will get a meta center somewhere over here, right? Now if this is the case, G is the point where weight acts, B dash is the point where buoyancy force acts, this couple will basically help the ship to restore its original position, and ship will come back to its original position, right? This is called restoring couple. Now the distance between G and M is called metacentric height. So meta center is above G. Now if you look at this particular orientation, this orientation is called stable equilibrium. So floating body is in stable equilibrium. Why? Because even after tilt, if you leave the tilt from the air, the body retains on its own at its original position or orientation. It means that the body is in stable equilibrium. Now if you closely look what happens to this meta center and G. See, in case of stability of submerged body, we were focusing on the relative position of center of gravity of a body and center of buoyancy. But here you have to keep an eye on the relative position of center of gravity and meta center. You see, meta center is above center of gravity. Meta center is above center of gravity. Metacentric height is greater than 0. See, metacentric height is measured as the distance between G and M, and it is positive when M is above G. When M falls below G, then the metacentric height becomes negative, and when M is on G itself, the metacentric height GM will be 0. Clear? So in this case, metacentric height is greater than 0. Greater the metacentric height, greater is the stability. Say for example, you have two different floating bodies, and you come to me saying that, sir, I have found the metacentric height of this body is let's say 5 meters, and for this body it is 5.5 meters. I would say the metacentric height for a body which has greater value, 5.5 meter, is more stable compared to this one. Clear? Let us now look at neutrally stable equilibrium. So let's say the body is tilted in such a way that the new center of buoyancy is somewhere over here, right? Now if you draw the line, and the line of intersection with the original or the previous center of buoyancy is somewhere over here on G itself. So your M is also on G. That means what? Weight is acting downward and the buoyancy force acts on the same line. That means there is no couple being produced. The body will stay as it is. It will neither come to its original position, neither it will fall back. That means the body is in neutrally stable equilibrium. Yes. And if you look at the relative orientation of G and M, they are both coinciding. They are both coinciding, if you see. And metacentric height is equal to 0 because GM is, distance is 0. Clear? Now if you look at another third criteria, unstable equilibrium. In unstable equilibrium, the body is in such a orientation where the new center of buoyancy is somewhere, let's say over here. Which will be what? This will be the center of the newly submerged portion of this ship, right? So B dash. Now FB acts in this point, C weight acts at this particular point. This will overturn the body. So this will create an overturning couple. Now if you look at the position of meta center, where is that? This line of action with this intersection is somewhere over here. So practically speaking, M is below G, and this will create the overturning couple and your ship will fall down. So that means here meta center is below center of gravity and metacentric height GM is negative because M has M has fall down from value of G also, right? It is below G. So metacentric height will be negative. So for all the floating bodies where metacentric height is negative, they are all unstable, they are all in unstable equilibrium. And for the body whose metacentric height is 0, they are in neutral stable equilibrium. And for the floating body whose metacentric height is positive, where M is above G, they are all in stable equilibrium. So let us just summarize whatever we have discussed. For a stable equilibrium, metacenter should be above center of gravity, right? And metacentric height should be positive. For neutral stable equilibrium, metacenter coincides with G and GM is 0. And for unstable equilibrium, metacenter is below G and GM is negative. So whenever you are designing any floating body, you must make sure it falls under the first category and it should be in stable equilibrium, and your metacentric height has to be as larger as possible. Clear? So I hope you understood this concepts. Thank you so much. For more such engineering concepts and videos, you can log in to our website www.clariconcepts.com. Thank you.